Sorry. If I start with the latter part of your question, does this affect the anti-vaxxers and people who are hesitant? Anti-vaxxers, I don't know if they will change in any way, but I think giving a Nobel Prize for this COVID-19 vaccine may make hesitant people take the vaccine and be sure that it's very efficient and it's safe. Now we have 13 million tests been done all over the world on people who's not experienced the disease previously. And we know it's a very safe and very efficient vaccine.
And the other question was if it will our decision toward will influence authorities.
I think if the FDA and EMA will be faster in a situation like this, I think they made the right decision to be very fast. In other cases, it may be wise to be a bit slower, I think.
Okay. Any additional question? Here's one, yes.
Hello, this is Caixin Media from China, and with the mRNA, we don't know the long-term effect yet. So do you have any concern over that?
Richard, would you like to respond to that question?
Yes. Of course, mRNA vaccines have only been given for a certain amount of time, which begs your question. Having said that, of course, the mRNA vaccine that is given is very transient, and the fact that 13 billion people have gotten the virus, vaccine virus, and I mean, the amount of side effects noted to date is extremely limited. So I don't think it's a major concern.
Anyone else want to add to that, or that's fine, I guess? I think that's.
Well, it can't be integrated into the nucleus, into the DNA, and that's, a safety precaution. The adverse effects that's been noted is mostly a mild myocarditis or perimyocarditis, mainly affecting young males, but that normally resolves without any long-term effects.
And maybe one could also add that the consequences of having COVID-19 can definitely have long-term health effects, as we know. So one always needs to relate the very minor effects of a vaccine to the severe risks of actually getting the disease. Yes?
Thank you, David Keaton, Associated Press. Obviously, throughout the pandemic, COVID-19 pandemic, we saw a very strong anti-vax movement, specifically targeting these new technology vaccines. As a scientific body, as scientists, what must this medical community do to try and breach this gap of trust between the wider audience, the wider public, and the science community to convince people that these are indeed safe?
Yeah, Gunilla, could you?
I think continuing to communicate how vaccines work, and for example, in the case of COVID-19, people felt that the vaccines were produced or developed very quickly. And that's true, because there was a huge need for that. But what these accelerated clinical trials did was not to remove any safety step. It was running things in parallel instead of sequentially. So there was no compromise in terms of the safety measures. And maybe that's not always understood. So, of course, communicating how it's done and all of the decades of basic research that's behind this kind of work, that's also not always appreciated by the public. But I think hopefully this prize can help highlight some of that, because this work has been going on since the 1990s.
Okay, here is one more up here.
Hello. Thank you. I'm from Chinese Nordic Time, and I'm happy. Actually, last year I'm sitting here and I asked the same question. So, well, mRNA vaccine will win the prize, but this year it gets a well-deserved prize. So I think everyone's happy with this. So the first question is about mRNA vaccine. So is there any other applications for mRNA vaccine in other diseases like cancer or like infectious diseases like this? So could you introduce a bit for the audience? And the second one is about long COVID, because I think now long COVID impact is I mean really important point for the society. So could you also let us know?
Maybe I'll ask Gunilla to answer the first part of the question and Olle Kempe the latter part.
Okay, so regarding other applications, yes, there's really quite a lot going on right now, and this is only going to increase most likely because we now have this increased safety data on the platform in general. But the main other applications I think we're going to see is, of course, many other vaccines against infections, particularly perhaps for flu, where we need updated vaccines. And that is one of the great advantages with this platform, is that it's flexible and fast, so one can update the vaccine if there's new virus variants coming, which we know happens all the time for flu. Other applications that are really sort of, there's going to be a lot of exciting findings, I think, coming out, and that's already started, is in terms of therapeutic cancer vaccines. So those are not preventative, but therapeutic vaccines, and they can either be done in a personalized manner or in a more general manner. Cancer is, of course, a very difficult disease, and it's in fact many, many different diseases, but cancer vaccines might very well benefit from this platform. And thirdly, there is many experiments and actually already clinical trials going on to deliver therapeutic proteins. And that can be replacing a defective enzyme, or it can be introducing an immunomodulatory protein. So in that sense, there is quite a lot of work that we will see, I think, apply to a variety of diseases.
So for the second part of your question, long COVID, well, first of all, vaccination prevents you from getting long COVID. Then long COVID is a spectrum of different diseases which ranging from the myocarditis that is usually much more prevalent if you get the COVID infection than from the vaccination. And it's also usually more severe. To long COVID, that is something we still don't understand the etiology of. And there is quite a lot of research ongoing on that.
Per. Varsågod. Ja, just det, du behöver en mick.
Yes, I'd like to ask you, Thomas, about Katalin Kariko's personal circumstances. You said that she had to leave her job, and could you just give me some more details about what happened to her and what the prize means now?
Yeah, I should say that I can only convey, and she essentially only told me what she has been telling in other interviews. And she's been explaining that her position, she never had a tenured position at University of Pennsylvania, and in 2013 it appeared as, from what she's saying, that it was hard to continue under those circumstances. She got a very senior position as vice president in a company, BioNTech, that later went on to make one of the vaccines. So she was not out of job in that way, but away from her family. She never received an R01 grant from NIH, which is a clear sign that she struggled and didn't get recognition for the importance of her vision. Because what was clear was that this is an extraordinary and unusual scientist who was very passionate about this idea of mRNA and using it therapeutically. And she resisted any temptation to sort of go away from that path and do something maybe easier. and maybe tell something about the funding situation, also being a female and being a foreigner and so forth. I'm sure it didn't make things easy, but she has not been complaining. She has also explained how happy she's been, and she was making progress through the years. So it was not that she was inactive, but she didn't get strong support, not the tenure, and the support to build up a big group. Instead, of course, she found very fruitful collaborations on the way. Yes. Is there anything more? I know several, or no, I didn't see that. So, okay. So I think then, I know several are eager to have interviews. So I think we'll close this part of the press conference right now. Thank you so much for coming, and apologies for the short delay in the beginning. Thank you. Ja, just det. Nej, men Ann-Marie, är det här papperna som...
Ja. De kan vi dela. Jag tänkte att jag skulle ta med mig ett. Har du på svenska också, eller? Ja. Var det svårt att få tag på dem?
Den ena var, det var det. Och en teknisk missöde med printningen faktiskt. Och sen blev det att jag behövde boka in och jag ringde